Hello and welcome, my friends. Today I want to discuss how to add and subtract rational expressions. So get yourself some paper and pencil because we're going to be doing some thinking. And thinking means connecting things. So let's have a good record of it. All right, if you think back to 4th or 5th grade, you may have had to do something like adding or subtracting fractions with unlike denominators. So you have to get a common denominator first. Now, one of my favorite questions to ask is, why is that? Because most people don't know why. Well, the denominator tells you how big the individual pieces are, right? A fraction is equal parts of a whole. All the pieces have to be the same size. And the denominator tells you how big the pieces are. The whole divided into 12 pieces or the whole divided into 15 pieces. And so in order to add or subtract fractions, you have to make the pieces all equally sized. And so that's what we're doing when we get a common denominator. But if you remember, you got to think about what the least common multiple is between 12 and 15. And so I was taught, like, you take 15 and just start multiplying it by 1 and by 2 and by 3 and see when you finally get a number that 12 multiplies into that as well. But how would you get a common denominator of things when you don't know what the denominator is? And that's algebra. Algebra is math of the unknowns. So let me do this very simple question slightly differently, and that will set us up for the method then for how to do it algebraically. What I'm going to do is I'm going to completely factor the denominator. So the 5/12 becomes 5 divided by, isn't 12 2 times 2, which is 4, times 3? Okay, and then minus from it 7 over 15. But isn't 15 3 times 5? Okay. Now, our common denominator is going to be, and I'll write it as one big fraction instead of two separate ones, and hopefully you'll see why here in a minute. Our common denominator is going to be every single base that's represented, and the greatest number of times it's represented. So if I come over here to the first denominator, I see that I'm going to have a factor of 2, and also I'm going to have a factor of 3. And now if I come over here to the other denominator, I have a factor of 3, but I already have that listed in my common denominator, so I don't need to add a new one in there. And then I need a 5. So I need all of the bases represented there, a 2 and a 3 and a 5, but I need it to the highest exponent. And if you'll notice, I've got 2 2's over here. Some kind of ballerina joke goes in here. I've got 2 squared, so I have to have it to the highest exponent. So the highest exponent on 2 in either one of the denominators is 2. It's 2 squared. What's the highest exponent on 3? Well, it's 1 over here on the left, and it's 1 over there on the right. So the highest exponent on 3 is 1. And then it's 5. And what's the highest exponent on 5? It's 1. So the common denominator right here of 2 squared times 3 times 5, that's my common denominator. Now we'll talk about what the numerical value is in the end, but let's go back now and let's take a look, because now I have to figure out what do I need over here on the left-hand side to get a common denominator? Well, I have 2 squared and I have a 3. What I'm missing is a 5. So if I multiply the denominator over here on the left by 5 and also the numerator by 5, because to keep the value of the fraction the same, we have to multiply the numerator and the denominator by the same thing, right? That's 5 over 5, that's 1. Okay, that then changes my numerator. So this is now going to be 25. Now over here on the right, what am I missing? What do I have to multiply the original denominator by to get the common denominator? Well, I have a 3 and a 5. What I'm missing is 2 squared. So if I multiply this side by 2 squared, sorry, it's a little cramped there. So times 2 squared, I get 2 squared is 4 times 7. I get my numerator part of 28. And now all I have to do is just do my operation on the numerator. What's 25 minus 28? That's -3 all over. And what is this down here? Don't multiply it out yet because you'll see why in just a second. This is going to be 2 squared times 3 times 5. And if you'll notice, I have a chance to reduce right here. This 3 and this 3 will cancel. And so my final answer then is going to be negative 1 over, what's 2 squared that remains? 4 times 5, negative 1/20. There's my final answer. Now, if you'd have done it kind of the way I was taught in school, which is actually find the number, the least common denominator then is going to be 60. And so what then do I multiply top and bottom by? Well, this one gets multiplied over here on the left by what, 5? So there's my 5 times 5, right? And then this over here on the right gets multiplied by 4, so that's times 4. And there's your 25 and your 28 right there. But how do you do it then when you don't know what the numbers are? You have to go through the same process of factoring. Okay, so the least common multiple of polynomials. To find the least common multiple of 2 or more polynomials, fully factor each denominator expression, right? It's the denominator that we want. And when I say fully factor, I mean we want to get it down to prime numbers. P-R-I-M-E. The least common multiple contains each prime factor and also the greatest number of times it appears as a factor. So that's what we did up here in this simple problem. We had to have all the prime factors represented. So I needed to have a 2 and a 3 and a 5 there, but we also had to have it to the greatest number of times it appears in the original problem, which for this one it meant we had 2 squared on that one. All right, so now let's look and see if we can find the least common multiple of these numbers here. And actually the variables are going to be easy. It's the numbers that are a bit hard. We got to get the numbers down to primes. So factor 16 down to primes. Well, the base is 2. That's going to be 2 to the 4th, and then p squared, q cubed, and then r. What's the exponent on r? Oh, the first. You don't have to write that. I'm just pointing it out. Okay, 40, prime factorization of 40. Isn't that 4 times 10? And isn't 4 2 times 2? And then 10 is 2 times 5. So I think what I get is I get 2 cubed times 5. And then if I do 2 cubed, that's 8. 8 times 5 is 40. So that's good. Times p to the first times q to the 4th, r squared. And now let me do the other one, 15. Well, that's simple. That's just 3 times 5. And then the variables are the easy part, p cubed, r to the 4th. Okay, now the least common multiple of all of these is going to have every single base represented to the highest degree. So I'm going to start over here on the left. What's my base? Well, my base is 2. Okay, and now I'm going to look through all the other 2's. I have a 4 over here on the left, and I have a cubed over here, and I don't have any 2's over here at all. So what's the highest exponent on 2? Well, that would be a 4. So that's my least common multiple of the 2's. Okay, done with the 2's. Do I have any other numbers? Oh, I have a 5. So I'm going to have a 5 in the mix. And what's the highest exponent on 5? It's going to be a 1. You don't have to write that. I'm just pointing it out. Okay, and so now I'm done with the 2's and the 5's. Do I have anything remaining? Oh, I've got a 3. And what's the highest exponent on the 3? Well, I've only got 1. So it's going to be 3 there. And now I'm done with all the numbers. I already got that 5. Now I go through with the variables. Times, begin over here on the left. P. I need a p. What's the highest exponent on p anywhere? It looks like it's p cubed over here on the right hand side. So p cubed. Done with the p's now. And then I'll go with the q's. I gotta have a q. And so what's the highest exponent on q? It looks to me like it's q to the 4th right there. So 4. And then r. Do I have an r any higher than 1? Yes, I do right here. Oh, look, I got r to the 4th over here. So r to the 4th. All right. So now I'm going to put all of this together. And let's get a final numerical value. The variables are going to stay where they are. So 2 to the 4th, that's 16. And then times 5 times 3. I get 240 p cubed, q to the 4th, r to the 4th. There's my least common multiple of those monomials. Again, it's each prime factor to the greatest number of times it appears as a factor. Alrighty, so now how about these? Oh no, these are polynomials. Okay, again, I have to factor them. So your factoring skills are going to be key here. All right, so the greatest common factor on the left over here, we'll start over here on this side on the left. The greatest common factor I can pull out right away is 3. So if I factor out a 3, what remains? M squared minus m minus 2. Okay, can I factor what remains? Are there factors of 2 that when I subtract them give me 1? Yes, the 3 carries along with it. It would be a 2 and a 1. So it's going to be an m and a 2 and an m and a 1. And then what do the signs have to be to give me a negative m in the middle? It would be a negative 2 here and a positive 1 right there. Okay, that one's down to primes. Now let me do the one over here on the right. And again, I have a greatest common factor of 4. So let me factor out a 4. I get m squared plus 3m minus 10. Okay, now carry along the 4, don't leave it behind. Are there factors of 10 that when I subtract them give me 3? Yes, it would be 5 and 2. So it's going to be an m and a 5, and it's going to be an m and a 2. How do I get a positive 3m? Well, that means I have to have the larger number positive. So positive 5 minus 2, there we go. Okay, so now put them both together. I have to account for each base. Oh, stop, hang on a second. Instead of 4, let me go all the way down to primes. Just to show you that, it would be 2 squared. Okay, so coming down all the way then in the end, I need to have each base represented. So I'm going to start on the left. I need a 3. And what's the highest exponent on the 3? It's a 1, and I'm done with that one now. And then no other numbers on the left. How about on the right? So I got a base of 2. And it's going to be 2 squared, and now I'm done with that one. Okay, going back over to the left now, I've got an m minus 2, so I need one of those. I don't know why I did circles. I'm not doing geometry right now, although that would be fun. M minus 2, and I look over here, I've got an m minus 2 over there on the right, but notice that they're both to the exponent of 1. So this is going to be a 1 over here, and this is going to be a 1 over here. So my final one is just going to be a 1. So now I've taken care of both of those. And then on the left, I've got this m plus 1, so I need one of those. M plus 1. Do I have any other m plus 1s? Nope. So I'm done with that one. And then anything left? Oh yeah, I've got this m plus 5 over here. So an m plus 5. And all of those binomials are to the first. So now if I clean this up and give myself a final number in the front, it's going to be 3 times 2 squared. I get 12. 12 times m minus 2 times m plus 1 times m minus 5. That is the least common multiple. There's bigger ones. Obviously, if you multiply everything through by 100, you can have a larger number. But it's the least common multiple, so that's what we're looking for. Why, you ask? Well, we're going to have to get common denominators, and common denominators are the least common multiples. All right, so now let's simplify this one here. Well, what's going on? I got 2 fractions, and I'm supposed to be subtracting them. Now, somebody's going to say through here, oh, look, I can simplify before I subtract. I can say, oh, that 6 is going to cancel with that 12, and that's going to leave me a 1 and a 2. And my answer to that is no. Stop it. Division does not cancel things that are added or subtracted. Division only cancels things that are multiplied. You're trying to tell me that 6 divided by, let's say, 5 plus 12. This cancels here and here, and this gives you 1 over 5 plus 2. That's equal to 1/7. No, of course not. The denominator is a group, and you have to treat it as an entire group. So no, we can't simplify by canceling things that are added or subtracted. We have to factor. But what we need to do really is we need to get a common denominator before we deal with these fractions here. So what I have to do is I have to factor the denominator. I don't really care about the numerator. Factor the denominator. So factor 2 out of the one on the left. The 2, that becomes x squared plus x minus 6 minus, and then this whole thing over here, 2. And x squared minus 4, isn't that a difference of squares? Yes, it is. Difference of squares gives me conjugates. X minus 2 times x plus 2. Am I finished factoring yet? I don't think so. I think I can factor that trinomial on the left side denominator. So I'm going to keep on going. So this now becomes 6 divided by, the 2 carries along with it. Factors of 6 that when I subtract them give me 1. That's going to be, say, x plus 3 times x minus 2. Okay, now subtract from that. I'm leaving myself a little bit of space. You'll see why here in a minute. Subtract from that 2 divided by x minus 2 and x plus 2, because I was finished on the right hand side. Now, common denominator, and I'm going to write it all over one fraction, and I suggest that you do the same. The common denominator says I need every base that's represented, so I'm going to take the 2, that goes in there. There's no other numbers. I'm going to take the x plus 3 from right here, that goes in there. What's the highest degree on any x plus 3 anywhere in the denominators? Well, it's just 1. I'm going to take this x minus 2. X minus 2 has to be included. Do I have any other x minus 2s? Yes, I do over here, but I only need it once. If the degree here is 1 on the left and the degree there on the right is 1 on the right, I only need one of them. I don't need both of them. And then, is there anything that I haven't covered yet? Yes, it's this one right here. So we need an x plus 2. Okay, whatever that is, that's my common denominator. And now here's the real trick. Now I have to decide what the denominator on the left needs right here to make it that one right there. Well, it's got the 2, it's got the x plus 3, it's got the x minus 2. What it needs is this one right here. It needs the x plus 2. So I multiply top and bottom by x plus 2. And now you see why I needed the space in there. X plus 2. So what I get over here on the left now is this. I get that. It's going to be 6 times x plus 2 on the left. Now, minus, that's that minus sign right there. What do I need on the right? Well, okay, so on the right, let me do it in this color blue. What do I need in this denominator to make it equal to the common denominator? Well, I need a 2. Okay, so here, let me make a little room here. I need that space. I'm going to multiply the bottom by 2 for this one right here. Okay, it's got an x minus 2 and it's got an x plus 2. It's also missing an x plus 3, so I need to multiply this by x plus 3. So in the numerator, right, it's times 2 times x plus 3. And now if I put this together, I maybe need the, I'm gonna combine those right there into a 4. It's 4 times x plus 3. And let me remove a little bit of the clutter so that you can see it here. All right. Now, a crucial thing is that it's, because it's minus here in the middle, because it's minus right there, it's minus whatever the group of the numerator is. It's minus the whole thing. And so a mistake that students make is they don't distribute that negative sign in there. All I need to do now is to do the operation on the numerator. So I'm going to draw myself a fraction bar again, and I'm going to copy down. I recommend that you don't fragment the problem. Some people will take the numerator off to the side and do it separately, but then sometimes they get distracted and they forget what they were doing and they never put the pieces back together again. So that's like doing a puzzle where you take a little corner and you play with it on the side and then you forget that you got all the rest of it there. I'm going to simplify the top. 6x and then plus 12, and then negative 4 times x is minus 4x, and then negative 4 times positive 3 minus 12. Don't forget to distribute the negative. Okay, and now collect my like terms. Maybe I'll go sideways for this because it helps me keep track of numerators and denominators. And so then 2 times x plus 3 times x minus 2 times x plus 2. And then 6x minus 4x, 2x. And then a positive 12 and a negative 12, they annihilate each other. Oh, look, I'm done with just 2x. Okay, but not done yet. Remember how we had something cancel in the original one, the example one? Same thing here, look. That's why you didn't multiply the bottom out. Don't multiply the bottom out, because if you're lucky, you might get something to cancel. So the 2 cancels there. How am I allowed to cancel the 2? Because it's multiplied both in the numerator and the denominator. And division only cancels things that are multiplied. So my final answer then is going to be x divided by x plus 3 times x minus 2 times x plus 2. And don't multiply the bottom out, just leave it like that. Whew, there we go. Adding and subtracting fractions. You got to get a common denominator. Good. So may your day be merry and bright, and may all your mathematics be right.